Construct SDT to convert given infix expression into postfix. So input is a plus b star c. So output will be postfix abc star plus. How we can see the grammar is same as we have taken earlier, E tends to e plus t oblique t, and t tends to t star f oblique f, and f tends to id. So the input which we make with this grammar, it will be like this: e plus t, then t star f. So it will be e tends to t, t tends to f, and f tends to id. T tends to f, f tends to id, and f tends to id. This is id, 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 id. So we can say a plus b plus c. So because it is postfix, so what is the output we are asking? Infix to postfix, because it is postfix. So first production rule, then we'll do print. And the second thing here, no attribute, because we only do print, and we are not evaluating any value. So how we will write it? Let's see here with the grammar. Grammar is given over here. So we'll write e tends to e plus t. So first what we'll write? We'll write print f plus oblique t. It will be like this, because what we are doing, we are printing what operator. Now t tends to t star f. So what we will print? We will print f star, and for f we can leave like this also, because nothing is there need to print, and or we can leave like this. And f tends to id, so we'll write print f id. We'll write printf id. So why we are doing like this? Because we are converting it to printf. So we can say simply after printf, after print, there is no need of any further calculation at particular production. So at f we can say simply we'll print id. So in that way we can see we are converting infix to postfix. So in because this is postfix, so first production rule, that is production rule, and then we are printing it. And because we are not doing any evaluation, only we are doing printing here. So we'll write like this for this grammar. In that way we can convert infix to postfix expression with the help of SDT.